Hello, today we're looking at operations on vectors. Okay, so let's see what we're asked to do. Okay, so we're given points A, B, C, D, and E, and we're asked to find the following. So in part A, find the position vectors for points A and D using unit vectors. Part B, the position vector for C using component form. The vector AC, the vector 2DE, and the magnitude of the vector DE. Okay, so let's start. Let's pick a color. All right, let's look at part A. Position vectors for points A and D using unit vectors. So let's start with point A. Okay, so what is the position vector? Position vector is this vector OA. In this case, O is just the origin. So the vector is 5, 2, or like A minus the origin. Okay, so what are the unit vectors? The unit vectors in this case, since we're in the plane or R2, so in R2, the unit vectors are I and J. Usually put a little hat over them to denote that they're unit vectors. And what are the coordinates of these two vectors? So I is 1, 0, and J is 0, 1. Okay, so now that we have that, we can rewrite our position vector for A as, well, we can do it this way. Let's do one out in detail. 5, 0, plus 0, 2. We're going to put our arrows over top. So this vector 1, 0 is just, actually we should put the little arrows over top, is I plus 2J. So this is how we'd write our position vector using unit vectors. So we went through a lot of detail for the first one, just so that you can see. Now let's look at D. Let's make it a little smaller. So D is now a vector. Let's write it out. D is a point, in R3. The unit vectors in R3 are I, J, and K. Because we have that extra component, the Z component. So our position vector OD can be written as I plus 3J plus 2K. A little easier. In other words, we just take out the components of our point and use them as the coefficients of our linear combination of our position vector using our unit vectors. Okay, so the first component represents the I unit vector. Second component represents the J unit vector, and the third component represents the K unit vector. Okay, that takes care of part A. Part B, the position vector for C using component form. Okay, all right, so in part B, we're pretty much doing what we started with in part A. So let's find some space for that. Okay, so we have a few questions and not a lot of space, but that's okay. Let's pick another color. Let's do green. So part B, our point C is 1, -1. Our position vector is OC. How do we find OC? C minus our origin. So it's 1, -1 with a vector over it. So that is our position vector for C using component form. Good. All right, so now part C, the vector AC. Okay, let's pick another color. So C, vector AC. Let's do C minus A. So C is 1, -1, minus A, our point A is 5, 2. Let's do, we are going to be subtracting component-wise, so 1 minus 5, minus 1 minus 2. So this equals -4, -3. Good. All right, so now D, the vector 2DE. Why don't we scroll over to the left so we have some more space? So let's pick another color. Let's do D over here. Okay, so first let's find the vector DE. Okay, so E minus D. E, our point E is -1, 3, 1 minus D, which is 1, 3, 2. We subtract component-wise, so -1 minus 1 is -2. 3 minus 3 is 0, and 1 minus 2 is -1. So that's our vector DE. So now 2DE is 2 times this vector. So we're going to multiply each component by 2. So then we have -4, 0, and -2. Good. And finally, C. Pick another color. I don't know what's a nice color. Light blue. So for E, we want the magnitude of DE. Well, we know what DE is. DE is this vector -2, 0, 1. So let's magnitude of DE equals. So how do we find the magnitude of the vector? We take the square root of the sum of the squares of the components. So -2, square root of -2 squared plus 0 squared plus -1 squared. Okay, so what do we have? We have 4 plus 1. So the magnitude of D, vector DE is the square root of 5. Good. So that brings us to the end of our video today, operations on vectors. If you have any questions, feel free to send us a note at info@raisemymarks.com or give us a call day or evening, and we'll be happy to help you. Thank you for watching.